Recall that the law of sines states the following. And also recall that triangles are determined by 3 parts out of 3 sides and 3 angles. We'll now review the needed information for the law of sines to solve a triangle. Case 1 is what we saw in example 1, where we were giving 2 angles and a side. This is denoted as angle, side angle, or side angles angle. The other case that law of sine will solve is when we have 2 sides and 1 angle. In the book, this is called the ambiguous case, and the reason why is because there's 3 possible solutions. Either there'll be 1 unique triangle, there'll be 2 triangles that satisfy the conditions, or it's possible that there's no solution. Let's look at a few examples that involve case number 2, where we're given 2 sides and 1 angle. Let's solve for all possible triangles with sides B is 25, C is 30, and angle B is 25 degrees. We'll go ahead and draw a schematic of our triangle. We'll call this side B, which is given by 25, which means this angle here is capital B, which is 25 degrees. We'll call this side C. This is given by 30, which means this is a capital C and this is a capital A. So this side over here has label A. So we have one complete sine and side. This is given by sine of B divided by B. And we can use this to find the other sides and the other angles. Since we're given the side C, why don't we go ahead and find what angle C is? So plugging in everything we know, we're going to get sine evaluated at 25 degrees divided by 25 is going to be equal to sine evaluated at angle C divided by 30. Simplifying this, we see that sine of C is equal to 30 divided by 25 times sine of 25 degrees. Writing this as a decimal approximation, this is going to be equal to 1.2 times 0.42262. Again, let me denote this as an approximation. Simplifying this, this is about equal to 0.5071. Then let's go ahead and write the trig equation that we have. We're given then sine of C is approximately equal to 0.5071. Using arcsine, we could write this as C is equal to sine inverse evaluated at 0.5071. And this is, again, approximately 30.47 degrees. Now we do have one more solution to this equation. And the other solution that we're going to get is going to be given by 180 minus 30.47 degrees. And the reason why is because in the second quadrant, sine is still positive. So the angle whose reference angle is given by 30.47 in the second quadrant will give us the same answer. So now we can break this down into 2 separate cases. In case 1, our angle C is 30.47, and in case 2, our angle C is 149.53. Let's solve the triangle for case 1 first. We know that the sum of the angles of our triangle should be equal to 180 degrees, and we know what B and C are. So what we can do is solve for A. Solving for A, we're going to get that this is equal to 124.53 degrees. Now for case A, we found all the angles. We have 2 of the sides, and so we need to find the last side. Let's set up sine of B divided by B is equal to sine of A divided by A. Filling in what we know for B, we'll get sine evaluated at 25 degrees divided by 25 is equal to sine of 124.53 degrees divided by A. This means that A is equal to 25 times sine of 124.53 degrees divided by sine of 25 degrees. After plugging this into a calculator, we get that this is approximately 48.73. Now, let's go ahead and solve the triangle for case number 2. Case 2 again, we just want to find all the angles, and we're given for triangles A plus B plus C needs to add up to 180 degrees. We know what B and C are. This means we can solve for A. Solving this for A, we'll get that this is equal to 5.47 degrees. Again, since we know B and the angle B, we'll set this equal to sine of A divided by A. Solving this for A real fast, we get A is equal to B times sine of A divided by sine of B. Again, B in this case is 25. Sine of A is sine of 5.47 degrees divided by sine of B, which is 25 degrees. Which, after simplifying, this is approximately equal to 5.6390. Before we end this problem, let's summarize the solutions that we found. For case 1, where we had that C was equal to 30.47 degrees, we found that angle A was 124.53 degrees, and side A was 48.73. And then in case 2, where our angle C was equal to 149.53 degrees, we had that angle A was about equal to 5.47 degrees, and side A was equal to 5.6390. And these are two different solutions for triangles that meet the conditions that we were initially given.